Welcome back to our artificial selection experiment. Last time, I showed you how to grow a population of Wisconsin fast plants and count their trichomes or hairs. In my population, the 10 fuzziest plants had trichome counts ranging from 14 to 29, and the 10 least fuzzy plants all had 0 trichomes. And then we went our separate ways to plan the details of how to manipulate trichome number in the next generation. Now let's compare notes. Here's what I'm doing. To continue with our dog breed analogy, I decided to go all out and create both a next generation of poodles, or super fuzzy plants with lots and lots of trichomes, and a next generation of American hairless terriers, or super not fuzzy plants with hardly any trichomes. Totally fine if you decided to just do one or the other though. This is my original plant population from the last video. They're all grown up now and have started to flower. I've marked my most fuzzy plants with orange flags, P for poodle, and least fuzzy plants with blue flags, H for hairless. Now comes the actual artificial selection part. To make my poodles, I'm going to take my 10 fuzziest plants and only allow them to reproduce with each other. To make my hairless terriers, I'm going to take my 10 least fuzzy plants and only allow them to reproduce with each other. No one else in the population gets to reproduce. We do not want any boring, medium fuzzy plants to add their genes to the next generation. Let's start with our fuzziest plants. To get them to reproduce, we need to transfer pollen between flowers on different plants. We don't want to transfer pollen between flowers on the same plant because they can't fertilize themselves. This is a very delicate process, so I'm going to use a paintbrush. I'm grabbing the pollen, that's this yellow dust, off the anthers of one flower and bringing it over to the flower on a different plant and putting the pollen on the stigma, that's this green bit in the center of the flower. And I'm double checking along the way that I'm only transferring pollen between my top 10 fuzziest plants. Now I'm going to do the same with my least fuzzy plants and a fresh paintbrush. And I'll repeat this pollination process several times over the next couple days as new flowers bloom. After I'm finished, I'll pinch off any remaining flower buds so the plant puts all of its energy into making seed pods. Don't pinch any open flowers you've already pollinated though. Soon the seed pods start to develop from the flowers I pollinated. About 20 days after my last pollination, I'll stop watering the plants so the seed pods get nice and dry. When they're brown, I'll harvest the seeds by crunching up the pods on a piece of paper and letting the seeds fall out. Make sure to keep your poodle and hairless seeds separate if you're doing both. Now I'm going to repeat the process from the first video all over again, planting my seeds, waiting for them to produce their first true leaf, counting their trichomes using the consistent method, and entering data. Be sure to re-watch the first video if you need a refresher on any of that. And if you're trying to make both poodles and hairless terriers, again, make sure to keep the plants and the data separate. At the end of all this, we have 3 trichome count datasets, one from our first generation of fast plants, and then 2 new trichome datasets from our second generations of poodles and hairless terriers. Let's pause for a moment to make some predictions. How do you think the trichome counts from our first generation will compare to our artificially selected second generation plants? Let's find out. First, let's visualize our trichome data across each population by making histograms. A histogram is a type of graph that shows the frequency of a variable in a population, in this case trichome number. You can make histograms by hand on graph paper or on a computer in Excel or Google Sheets or R. I'll let you pick your favorite or follow the workflow your instructor has advised and just show you my results. Let's start by comparing the first generation and second generation poodle histograms. On the x-axis is trichome number. I've made sure my histograms have the same x-axis spanning the full range of trichome number in my datasets. For me, that's 0 to 42, but the range of your x-axes will likely be different from mine. On the y-axis is the frequency at which a given trichome number appears in our population. So in the first generation, 48 plants have 0 trichomes, 33 plants have 1 trichome, etc. And in the poodle population, 18 plants have 0 trichomes, 20 plants have 1 trichome. Keep in mind the ranges of your y-axes might be different between histograms because the population sizes and trichome frequencies are different. By comparing the 2 histograms, we can really see that artificially selecting for super fuzzy plants had a pretty big impact on the distribution of trichome number between generations. In our first generation, 0 trichomes is the most frequent number in the population. But when we artificially selected for a second generation of poodles, individuals with 1 and 2 trichomes are just as frequent as those with 0. In the first generation, plants with more than 14 trichomes are rare. But in the poodle generation, we see plenty of individuals with up to 20 trichomes. This generation just has higher overall trichome numbers. And then our extremes far exceeded what we saw in the first generation, with super fuzzy plants having up to 42 trichomes. We would say the trichome distribution in the poodle generation has shifted to the right compared to the first generation. We see a similar trend in the opposite direction when we compare the first generation with the second generation hairless terriers. The vast majority of the population is totally hairless, with 0 trichomes. We have this one random outlier with 17 trichomes, but basically the entire population never gets above 7, so the hairless terrier distribution has shifted to the left compared to the first generation. Now let's boil our trichome population data down to a single number, the average trichome number per plant. Any data analysis software you're using will have a function to compute the average. So the first generation has an average of 4.4 trichomes. Poodles have an average of 7.6 trichomes. And hairless terriers have an average of just 0.7 trichomes. Okay, so based on the data exploration we just did, it looks like our artificial selection experiments had a pretty big effect on trichome number. But how do we know these trends are legit? Like, what if they're just due to randomness? Or what if, an average increase of 3 trichomes per plant isn't actually that big a deal given the overall population structure? Luckily, there is a statistical test we can perform on our data to assess our results. It's called a t-test, and it'll tell us whether the difference in average trichome number between the first and second generations is statistically significant. Thanks, math, for saving the day! Again, pick your favorite software to perform your t-tests. I'm using Excel, and we'll start with a t-test to find out whether the first generation and second generation poodles have statistically significantly different average trichome numbers. Whew. The one thing I want to point out is that you'll always enter the entire dataset for each of the 2 populations, not just their averages. The t-test assesses the average in the context of the population-wide data. Okay, we're all set. Now it's the moment of truth. Gonna look at my results. And it's kind of an intimidating table. Ugh. This will generally be true across software platforms, but don't worry, the number we want to focus on here is the 2-tailed p-value. The p-value tells us the percent chance that our first generation and poodle plants would have had those trichome numbers we recorded if there were no real difference between the populations. As you can see, the p-value is 4.96 times 10 to the negative 5th. That's 0.0000496, so there is only like the teeniest, tiniest, itziest, bitsiest chance that our trichome data doesn't represent a real difference. In other words, the difference in average trichome number between the first generation and poodles is statistically significant. Generally, we consider a p-value less than 0.05 to be significant, so we have definitely hit the mark with this t-test. Let's do another t-test for the first generation versus hairless terriers. And our p-value is 6.83 times 10 to the negative 20th, so yeah, I'd say that trichome number is for sure significantly different between these populations as well. So in just one generation, we've gotten significantly different trichome numbers in both directions. Wow, we've just witnessed the power of artificial selection. I'll leave you with some fuzzy food for thought. What do you think would happen if we kept the experiment going for several generations? Would the experiment have worked for any type of trait? Would we see such drastic changes over a single generation through natural selection? Pro tip, best to think about these questions while you pet a fast plant. Or better yet, a puppy! Oh, yes, yes, good boy, good boy, yes. Oh, look at that. Oh. Good boy. Oh, good boy, Juju. Oh, yeah. Oh,